Welcome friends once again. So today I would like to talk to you about server-sent events. So server-sent events are pretty much straightforward. They work more or less as you would with WebSockets. The only difference is that with WebSockets you have bidirectional communication between your backend and your frontend. But with server-sent events, you only have a one-way communication from your server to your client. And of course, this is quite useful in scenarios where you still need to have real-time update of data, but more or less you would need your server to only listen to those events and not having to send a return message back to your server. So you could use this in scenarios where you would want to have, say, notifications, or you would want to update a certain part of your DOM when a certain event comes to the backend and stuff like that. And it's really pretty straightforward. If you've watched some of our videos where I explain how to work with WebSockets in Go, this is pretty much similar. There is not so much difference between the both, and I'm just going to show you how easy it is to actually work with this in Go. Of course, I have another video where I explain how you can achieve the same with Rust, and of course, feel free to check this out if you're interested or if you work with the Rust language. So without further ado, I'm just going to jump right in. So I have, as you can see over here, I have a repo where I put in a lot of I call them general issues, as you can see over here, and here I just have a lot of general topics, and I will also share this repo so you can also check it out if you're interested in it. I have a couple of problems that I've already tried to solve in this repository, but I'm gonna go ahead and create another folder here. Now I can call this server sent events. It's also gonna be pretty similar to these other ones, and in here I'm gonna create a single file called main.go. So this is actually where I'm gonna add all the logic we need for this. So it's really gonna be pretty straightforward. So package server sent events, and of course we need a server, and I'm going to keep this as simple as possible. So I will not be doing this with Gene. I'm just going to be doing this with like the net HTTP library that comes with Go. So I create my main function, and now I'd like to actually it's going to be a really simple server. So I'm going to set up a server HTTP listen and serve, and I'm just going to have this at port 8080, and for now make this as new. And of course this is already enough to have our server live, and actually I'm just going to make this all caps so I can export it. And then maybe here I can add an endpoint. I can create a simple endpoint down here. I can call this health. Yeah, I think that's fine. So it's going to take a response writer, and a request, HTTP request. And for now, this is not going to be doing much. I'm just going to maybe just print some things back to the user. So maybe from the request, and I can say something like I need the request URI, this one, and that's fine. And maybe I say something like you have visited the endpoint, and I'm just going to print this URL, and then I'm just going to come over here to hook it all up. So http.handle func, and I provide the path. So this is going to go to /health, and now I'll pass our health endpoint, as simple as this. And then I'm just going to come into main and import that. So I'm going to call this server sent events main, and of course I'm going to comment this other one out. That's it. So now I can run our code. Go run main.go. This should be able to start up a server for us actually at port 8080, and we can confirm this by making a call request to localhost 8080 health, and then we get like we said, this this is the message we have over here. So now what I'm gonna do, at least you can see we have our server up. This is actually a pretty straightforward one. So but now I would like to create a function that's going to handle more or less our server sent events. So it's going to expose one additional endpoint like we have over here, and then handle the communication first. I'm just going to copy this and duplicate it, and I'm going to call this event handler, and I'm going to duplicate this part as well. And here, of course, I'll use my event handler, and then I can call this events, something like this. And now, so of course, it's not going to just print the message for us. So I'm going to set up a couple of information in the request that's going to be returned to the response, more or less, that's going to be returned to the client. So first, now, what I would want to do would be to set up my course headers. So this is I'm not gonna set it just to allow all origins. Say allow all origins, and it's pretty straightforward. We just use this header function and then call the set method, which takes two values. One is the key, one is the value. So here I would have my access control allow origin, and the value is going to be, of course, like I said, everything. I can actually get rid of this. I don't need this anymore. And I would like to set a couple of headers to the response. I'm just going to maybe duplicate this a couple of times. I don't know. Let me see if I need all of that. So I need access control allow origin, and I need access control expose headers. And for here, I'm just going to put content type for now. And what else do I need? And I would like to set maybe content type. And what can I set this to? Maybe I set it, of course, this should be of type event stream. The next thing I might want to send will be my cache control, and I'm going to set this to no cache. And the last but not the least, what I would like to set in the header would be, of course, my connection, and I'm going to keep this to keep alive. Yep, and that's all the headers I would like to set. So now I'm going to set up a couple of things. So one is I would like to of course be able to flush the HTTP, more or less, so to be able to flush the buffer. And I'm just going to keep this quite simple. So I'll create an argument, and I can call this flusher, and I have an error, and this is going to come from, of course, we'll get this from our HTTP flusher. So HTTP flush like this. And for now, like I said, I'm going to keep this simple, so I'm just going to forget about the error. And I need a channel I'm going to use to, of course, handle the closure. So when everything is done, I would like to use this channel to close everything. So I can call this a done channel, and I make the channel like this. And I can, of course, it's going to be of type Boolean. And I would like to create another channel, because I'm going to simulate like a constant flow of data. So of course now I don't have data coming from anywhere, so I just kind of have to simulate this myself. So I can say tasks. This is going to be the channel I'll use to manage what I'm just going to be writing to the events, and I'm going to call them tasks. So it's going to be a channel of some type. I can call this task, or let me keep it simple. I can call this events chan, and I call this events. So I need to create a struct of type event struct, and I'm going to fill in of course the tabs much later. That's totally fine, it's not a problem. And now, so we have our channel. So the first thing, of course, I would want to do is to handle these tasks, these events rather. So I need to create a function more or less that's going to help us to handle this. So basically going to help us simulate constantly this event and then write it into the event channel. So because of that, I'm going to create use the go routine to more or less create this function. It's going to of course be headless. I'm just going to give it any value or name rather. And so it's going to be a finite for loop like this. And of course I need to of course provide this way. It's not going to take any arguments. I'm just going to leave it like this. So I have my events chan. So this will be my channel, and I need to write into it, and this will come from my event like this. And that's more or less what I need to do. So this is going to constantly write into my channel, and now I need to of course handle more or less the closure. So if we are done, so this is going to help me handle the connection to the client. So again, I create another go routine function like this. I use this, of course. Nope, that's not what I need actually. This is more or less what I need, and this is going to be pretty straightforward. I'm going to read from the context from the requests, and of course I need this method, and then now I can call my done channel and of course write this into it. So now it's going to be true. So when the client terminates the connection, more or less I would like to of course gracefully handle the disconnection. That's totally fine. So now I would like to simulate. So this is actually the form part, and of course I need an infinite function more or less here. And now this is when I read out of the channel. So remember, this is constantly writing into this event channel, and now we need to constantly read out of the same event channel and then decide what we want to do with the event. So here I create a single event. So this we would get from the events channel. So we read from it, and I need to use the select method to handle the different cases that we could have with our more or less with reading with our channel. So the first thing I would like to of course handle would be if the user should close the connection. So here this is of course I need to add a colon here. So if the user closes the connection, what we need to do for now, I'm just going to return, of course, that's totally it. But maybe I'll leave a comment in here so I can see something like clients disconnected, and I can maybe add a clean up resources, something like this. That's totally fine. But if that's not the case, of course, if the client is not trying to close our events, to close the connection to our server, we would constantly process events. That's just all we're gonna do. And so what I would want to do more or less is to marshal this event into a string. Of course, first marshal into bytes and then convert it into a string, and then flush the buffer more or less. So pretty straightforward. I can say JSON bytes. We also need an error, and this is gonna come from json.marshal, and I would like to marshal this event that we read. I hope it was imported for us also. So, and again, I can actually take this. I don't want to care about this for now. And now I can here, maybe I call this results, and I can convert this to a string. And now what I can use fprint for now to keep it actually pretty simple. I use fprint to more or less write this into the response buffer and then flush it afterwards. So here I can say something like data, which is going to represent what we are sending, and then I need to provide some strings and then some new lines, and that's more or less it. And of course, this is now when I actually write what I need to write, and this is the message that our client is gonna get. So I can say something like event. I'm gonna pass a string, and that string will be this res that we have over here. And then other than that, I would like to sleep for a while, and then I'm just gonna maybe sleep for 2 seconds. So 2 times time dot second. I'll sleep for 2 seconds, and then I use my flusher function, and I call flush. I flush the buffer basically. So again, like I said, what we have here is actually pretty straightforward. And maybe I can completely collapse this for now, so we have enough room. So we have this over here, which is more or less constantly writing into the buffer, into our channel, more or less our event channel. And then over here, of course, we have this to help us handle graceful disconnection in case of disconnection from the client. And other than that, we have this infinite for loop that constantly listens to our channel for messages, and if there are messages, then it rises to the client. This is actually what we have, and it's pretty straightforward. And maybe I probably need to add more information to this struct so we can see this in the front end. So for this, I can have one, I can call this, I want to keep this as simple as possible. So I can say maybe I can have one that says attempts is going to be an integer, and of course I need to add this for easy serialization and deserialization. I call this attempts. I hope I spelled that correctly. And I can have another one called data. This is probably going to be a struct. I'm probably going to put 2 things in here. So I have item, and it's going to be, again, I need to provide some info for just serialization and deserialization. So I have item, and I can have another one called value. Is also going to be a string. I'm keeping this quite simple and straightforward. And again, value, and of course for the roots, of course, this other one I need to provide more information. So I can call this, of course, data. That's fine. Attempts, and now I can actually provide some information here. Because if we smash out this now, of course, we're basically not going to see anything. It's just probably going to be empty actually. And so here I have attempts, and I can use, I like to generate a random integer here. It's going to be between 1 and 100. Let's keep it as simple as this. Are you able to import this for us? No, yes, no, it doesn't. Okay. No, I don't want the one from crypto. Okay, and now I need to maybe provide, of course, a value, and what did we call it? Actually, we have data, and I shouldn't have defined this way, but it's fine. So our struct, which was, we had item, which is a string. I'm just going to copy this. Actually, I don't have time to waste here, and I just put this in here. Oh, come on. I'll place that with this, and now I provide this, of course, item. I give this maybe an empty string for now, or I say item, whatever. And value, this can also be value. And of course I need to put a comma here. That's totally fine. And now, so we have our value here, more or less, and this is going to write straight into our event channel. So what we can do, of course, would be to restart our server and see if everything works still. So it seems to be up. We try to go here, and this seems to be fine. And now we can actually test this from the browser to see if everything works as expected. What I can actually do is maybe to see if I can I don't know if this is gonna work, but let me give it a shot. There's no harm in trying. And yeah, so we see here actually, so there's no need to go to the browser. We see our events constantly being streamed, and of course, if you remember what we did here, it sleeps for 2 seconds and then flushes the buffer, and then we get a new one. And so that's more or less it. Maybe what I can do is actually provide a function, and then we can, because now it doesn't seem like much, the only thing that's actually changing is just this field called attempts. I can add a new function to more or less give us a random string, and then we can of course make see some randomness. So I will do that right away. So I can come down here and create a function. I can call this random string. It's going to take an integer and then it's going to return a string. And I'm keeping this as simple as possible. So I can call this, I can have a variable here. I can call this len runes. I would like to create a slice of ruin, and this would be here. I'm just going to add all the alphabets. I'm quickly just going to type this. So this is what I want to have. So sorry, all the characters of the English alphabet. Maybe I can also make it interesting and add. No, I think this is fine. It's totally fine. And now what I want to do is more or less to now given what's the number that the user has provided over here, I'll return that amount of strings. So here I can create I can make a new ruin or ruin slice more or less. Is gonna be of length n, and I would like to now append to this new ruin slice that I created. So for I, and I need to range over b, I will need to of course append more or less to that at that index. So I say len ruins, and I need to use my rand rand.int this one, and I need to provide the len of my len ruins like this. And then other than that, when everything is okay, I simply return. I'm going to convert this to a string, and I return b like this. And now what I can actually do is use this function, come over here, and of course it doesn't make sense as you can see, but I just want to have some randomness. I need 10 characters here, and maybe here I need, I don't know, 6. And now I can restart this server, and we'll try that one more time. And now we'll see some randomness. So this of course you can already imagine, like I said in the beginning, if you have an application and you would like to maybe listen to certain events from the server, and then maybe do things like update some charts or show the user some notifications or whatever the case might be, and if there is no need more or less for the client to return or respond to the server, because again we said that server sent events are more or less unidirectional, so you can only send events from the server to the client and not vice versa. If you would like to have bidirectional communication, of course WebSockets will be your communication protocol of choice. But anyway guys, that was a rather quick one, and yeah, I wanted to just show you this one as quickly as possible. And yeah, again, I'm going to leave a link to the WebSockets tutorials that I already have, so in case you would want to check it out, or if you have functions in that regard. And of course, if you are a Rust developer, also check out the same implementation we have over here for server sent events using the Rust language. And yeah, that will be all guys for now, and until next time, have a lovely evening, and bye bye. If you would like to listen to this event from the client, maybe from a simple HTML file, and that's also pretty straightforward. So I'm going to also create a file in here, and I can call this SSE, that's HTML. I'm going to also provide a link to the MDN docs if you want to read more about this. But of course, this is referred to as event source. So I'm going to write a simple HTML file here. So it's actually going to be pretty straightforward. So I'm going to add a head, and in here I'm going to add some title, and I can call this SSE example. Is going to be pretty straightforward actually. So provide a body. Within the body I'm going to provide a div, and this div is going to have an ID. I'm just going to give it so SSE data. So this is going to help me to more or less know where to update. It's really going to be quite straightforward. So I provide a script, and in here I would like to now create an event source. This is going to come from, like I said, the event source API. I'm going to provide again the documentation to the MDN docs if you'd want to check this out. So it's going to be at http at localhost, that type of right, localhost 8080, and it was at events like this. And what we're gonna do is actually pretty straightforward. Is again, like I said, it's quite similar to WebSockets. So I can say event source dot on message. So when we have a message, what should happen? I need to provide a function. The function is just gonna take the event, and what it's gonna do is actually basically just append this to this div that we have over here. That's nothing much for now. So here I can provide my element, create a new variable called element, and now I need to get element by ID. So the document that gets element by ID, and I provide the ID. The other ID would be like we have up there, SE data, like this. Like this, and now I would like to append this to, of course, I'll add it just or modify the HTML of what we have within this div. That's really what I'm gonna do. So I append this way, so I need a plus sign, not a multiplication sign, and I have event.data, and I would like to add a line break. So of course I need to add this as a string. So I'm like add a line break like this, and that's it. Actually, that's all the code I need to consume this server sent events. And what I can quickly now do more or less is to show you this, open this on the browser and show you what it looks like. So as you can see, I've opened the HTML file in the browser. As you look over here, there's actually not much going on, just the single HTML file that we created. But if you can see, the amount of code we needed to that wasn't actually much. And then if I can actually inspect the page and maybe go over to the network, maybe I can refresh this again so we can see what's actually going on. So if we come over here, you actually see the response coming. So it behaves more or less like it would when we were working with WebSockets. Remember, the only difference would be that this only allows unidirectional communication from the server to the client, and that's it. Anyways, that will be all, guys. That will be all for now, and until next time. Of course, if you're new, please go ahead and subscribe and leave me comments, leave your questions, and I will get back to you as quickly as possible. Have a lovely evening, and bye bye.